on slides, but I'm not going to finish in 1 minute. If I were to ask you what kinds of traffic delay is to your benefit and worth your time, how about the delay caused by construction work zones? Many of us have the experience of crawling on the freeway just because the work zone ahead. You may think, I know these construction workers are saving my life from this bumpy road, but is it possible to save my travel time? Well, they are at work. To reduce the travel time, we must first need to estimate the traffic states near work zone area. Is it free flow or congested? A simple and a straightforward idea is to place sensors near work zone area. But what if a sensor fails? Study shows nearly 40% of traffic data is missing due to sensor faults. How can we make a good estimation even with sensor faults? This is the question my research seeks to answer. My name is Shuming. I'm developing a sensor fault diagnosis. It mainly consists of 2 steps. First, a sensor detects the traffic states directly and makes an estimation. And second, a backup estimation is made for this sensor in case it fails. Now, there are many methods to generate this backup estimation, but they require large historical data sets, which we don't have at work zone area. I do this differently, using this dare or not game. It doesn't make sense. Okay, hear me out. Dare you touch this kettle if this thermometer tells you this boiling water is 20 degrees? I hope not. The big difference between your guess around 100 degrees and this reading 20 degrees makes you think this thermometer may fail and you better trust your guess. Similarly, I made a backup estimation using adjacent sensors. Once the detection is as ridiculous as this 20-degree boiling water, a sensor fault is detected, and we can use our backup estimation to back up what we guess is wrong. In this way, we can make turn and provide reliable traffic estimation and avoid the requirement of big data size. My goal is to use this sensor fault diagnosis to pave the road for traffic control strategies. Hopefully one day, with my device system, when you come across a freeway work zone, you don't feel as painful as touching this 20-degree boiling water. Thank you. Questions?
No, I'm afraid to ask a question in case it's a 100-degree question and I get a 20-degree answer. Can you give us some idea of the kinds of sensor networks you're talking about?
So specifically, I first built a traffic network from the real world, and then use that realistic measurement from the California website. They have the Freeway database. So I use their measurement, the realistic data, to calibrate my models, and I implement what I got here, using all the algorithms I have to do the simulation. Of course, you cannot test your control methods on the real transportation system. It's very dangerous because it's a safety critical system. So what I do is just try to mimic what happens in real life and use my methods to test what I saw or what I developed. Thank you.
Will you be looking at the time series data? And if yes, can you do fault diagnosis or traffic anomaly detection on the time series instead of other sensors, for instance?
What do you mean the test sensor?
How are you going to be collecting the data right now? You said you're doing modeling, traffic modeling.
Yeah.
Okay, and you will get the data, real-time data, to validate the models, right?
Yeah. So,
would the data be enough to give you an understanding of the network without the models themselves?
So if you go to the California website, they provide the data from loop detectors and also other Bluetooth, the magnetic sensors. All those data are available. It depends on what kind of data you want to use. In my case, I only deal with congestion states. Let's say if you can travel like say 100 kilometers per hour on this freeway, there's no need to control the traffic, right? You just go 100. Nobody, like, unless you go too high, cops just stop you. So if you go, let's say, too congested for work zone area, you may go as low as 20 kilometers or 30 kilometers. What I do here is try to make you, let's say you go from A to B because this work zone, it takes 10 minutes to get there. But using the system I developed, you probably take, let's say, 7 minutes or 5 minutes. It's just to save your time. Normally, you probably only need 1 minute. But we're not the magicians. We cannot make you still travel 100, so many cars. But what I can do is try my best to save your time. So from the results I get, the travel time I get is reduced around like 15% compared with no control at all.
I'm not sure if I understood everything well enough, but I think I have a question, which is, what are the types of failures that you might incur in this situation?
The filter.
Types of failure. So is there only one type of failure, or there could be multiple modes of failure?
So for now, I consider multiple sensors, and the multiple sensors can be sensor A fails or sensor 2 fails. This is the scenario I care about. And regarding the specific type of the faulty type, I consider this sensor send 0 flow rate with the presence of vehicles. So this is the type of faulty sensors I consider. But now I consider multiple sensors. If, let's say, one sensor fail, two sensor fail, or both sensor fails. How does it work for this system? What's the impact? How can we mitigate the congestions even with the sensor faults? Thank you. Okay, thank you.